Hi, this is Jeff from the Ozark Mountains. That's in Missouri, in the USA. Today, we've got a sick Epson HX-20 here on the bench. And, of course, this needed recapped. These always do. But it has a very interesting problem with the keyboard. And according to Epson, this particular style of keyboard is non-repairable. But, you know me, we're going to try to repair it. And, to help to do that, we're going to use this. This is a very fancy FLIR infrared camera, which one of the professors at work was nice enough to loan me for the weekend. So let's have a bit of a more in-depth look at the problem this guy's having, and then we'll get the camera out and see how we're going to use it to try to fix this keyboard. Let's get started. Thanks to PCBWay for sponsoring this video. They do circuit boards of all sizes, small circuit boards, medium circuit boards. They can even assemble them for you. Are you a maker who likes sharing your ideas with other makers? If so, you can submit your articles to the monthly submission for PCBWay and earn coupons and notary titles. Check out the link in the description below. So we'll go ahead and turn this guy on, and at first it doesn't look too bad. It beeps, it gives you a display, it's got some garbage programs in here because it needs to be reset, and to do that you press Control-At, and this all looks okay at first, and as soon as I hit a key, like if I wanted to hit 3, it'll just keep repeating the last key I pressed and go on and on and on and on until it locks the computer up. Very, very curious. And I got out my HX-20 and I swapped keyboards between the two, and the problem followed the keyboard, so it's actually a problem in the keyboard matrix itself. It's not, a fancy keyboard with serial interface and, digital electronics. It's just a bunch of keys and some diodes. In investigating the keyboard and ohming certain things out, I noticed that one of the lines from the ribbon, there's a line that goes from the ribbon cable to the keyboard that's kind of high resistance. I was able to jumper that with a wire, and that didn't make any difference. And all these diodes here are for the columns in the matrix, and I found there was a short between two of them. I'll pop up the schematic here to show where that's at. And I lifted those two diodes, which meant that all the keys with the keycaps removed here wouldn't work. But that didn't solve the problem. There's still the short there, and so when it tries to scan the keyboard, it's getting back some key code that it doesn't understand, and it's confusing the scanning routine. Let's pop this guy open. Here is what the HX-20 looks like when it's open. This wire I've got taped over here was the one I soldered in to replace the bad connection in this ribbon, which is on this side. And fortunately, there's a via over here we can solder to, but that doesn't fix this problem because of the shorts here. My plan is to pull this keyboard out, and we'll solder a couple wires onto these vias up here, which gives us a connection to that row. We'll disconnect the two diodes again, so we're only basically connecting to where that row is, and we won't be going through the diodes or anything else. We'll run a small constant current, say 10 to 50 milliamps through that short. And with our fancy infrared camera, hopefully that'll illuminate where it's at on the board, because it goes all over the place. So there's no way to track it down. And the way this keyboard's built, it is a PCB with some sort of mylar insulator sandwich on top. And you can see all these little heat stakes right here. The keys are in groups of 4 or 5 in little modules that are heat staked down. So if we can find one particular area and remove one particular set of this key modules, we might be able to fix it. If we have to remove everything, I think the keyboard's done for. There's actually 2 different types of keyboards on these HX-20s. There's this later style, which has this mylar overlay. It's a carbon printed type of thing. They are not very repair friendly. There's an earlier style which uses cherry key switches. They're not MX switches. They're a different lower profile type that, you know, if you can find the key switches, you could repair those no problem. But this style is kind of a pain. So we'll go ahead and get the keyboard pulled out. And we'll get some wires soldered on there. And then I'm going to let it set and everything come up to room temperature, so we'll have a better shot at catching where the short circuit is with the infrared camera. Little handheld shaky cam here. Here is a overview of our experimental setup. We've got our FLIR infrared camera here. The circuit board is propped up on this box, and I've got a couple wires soldered to where the diodes were. And it is going to the Extron upscaler so I can see it on the big monitor and the video capture. And we should be sort of in focus. Now, you'll see this on the video capture. All I'm doing is moving about 1 meter away from the board. And there's enough of a thermal difference in the field of vision of the camera that it's seeing it. That's kind of awesome. The first thing we'll do is use the ohm meter here so you can see the short, and we'll see if even the current from the ohm meter makes any difference on the IR camera. So we've got about 22 ohms. And we can't see any thermal difference on the board, but I'm kind of clouding it with my body heat. Okay, so we've got about 22 ohms right there. Turn on the bench power supply, which is set to output 20 milliamps. That's the lowest I could get it. Now, if we turn the power supply on, nothing showing up so far on the IR. I don't know why I'm clouding it so bad. Here's my hand for reference. It's the temperature difference there. Okay, output off. Now we'll set the current. This should be about 30 milliamps. It's 41. I'm more behind the camera. See, we've got a kind of a bright spot in the upper right hand corner. All I'm doing, when you see the image shifting, I'm 18 inches behind the camera and I'm just moving and it's affecting the image. Yeah, kind of just in this upper right hand corner. That's the only bright spot I really see. That's near the 1 key. Let's turn the output off. I'm going to set it to 40 milliamps, kind of on the lower end of the resolution of this thing. I bet we'll get like 50, 60 out of it. Output on, we're at 51 milliamps. Yeah, we still got a bright spot in the upper right hand side. And if I place my hand near there, I don't want to touch it because I'll leave a heat signature on it. You can see my thumbprint. I had my thumb on the mat, and you can see that you can still see the glowing of my thumbprint. The lab I borrowed this camera from was nice enough to set up this simple example that could be shared. The work they were currently doing couldn't be shared, but here we show the camera and the sample, and we have a 50-watt microwave transmitter, which is providing the heating source. And for this example, there is a small amount of water that has gotten under a rubber membrane, which is taped down here. And we've got a video of the results. Remember, this camera has a sensitivity of 0.35K. You'll notice the temperature scale on the right in this video. The entire range is only about 3 degrees K. It is quite sensitive. Here are where the two bright spots were, according to the infrared camera. And of course, there's nothing on this side of the board that we can see that, makes any sense there. On this side of the board, the keys are in these sets of 4. There may be also sets of 3, but they all look like sets of 4. So we've got a circuit board, some type of 1 or 2 layer membrane thing here, and it's all same. This is like a self-adhesive thing too. And these sets of keys are put through and heat staked on this side. You can see I've removed this one heat stake. I put a blade like this in my little X-Acto knife and just kind of carefully wiggled it like that. Try not to let it go all at once. You can see I need to go from here, kind of in these 4 sets of 2, and that should release those 4 keys. And I don't know if this section below it, see, that's right where that other short was, and it's right in the same one of the 2 columns. I took all the keycaps off that were involved in those columns, and you can see they're all over the board, so there was no way to try to localize it. Although I did notice the only key that seemed to make a difference when I pressed it resistance-wise was number 1. I didn't show you that on video, though. I apologize. It dropped resistance just slightly. So maybe that was also a clue. So I'm going to remove the rest of these heat stakes here, and then we'll see if we can pop the keys off of there. Now the heat stakes, it's the plastic sticks through the board a little bit, and they take a heated probe thing and go like that and smash it down there. So it's a real quick and easy, and most of the time for something like this, it works perfectly fine. And I imagine for something like this, it's all automated. Once it's assembled, they can do many of them or all of them at the same time. Yeah, it's stuck to this. Okay, got that one kind of started up through there. There we go. Okay. The other thing we got to be gentle of is these ribbons. What's that right there? Got kind of a shiny spot. Kind of a shiny spot there too. Shiny spot there. Okay, let's look at the keys. Oh gosh, these could fling apart at any time. So these are a little rubber pad and a spring. Okay, so there's nothing conductive to those. They're just pushing down here, which is where we kind of see this strange spot here and here. Now, how about that? I've got those leads hooked up, which are across those 2 keyboard columns, and we don't have a short unless we press right there. Oh yeah, it's right under where this spot is. Curious. Okay. Yep, it's definitely right there. That's what's causing the short. 12 ohms, yeah. The lowest I saw it was about 13 ohms. Okay, so we'll try to peel this apart now and see what happens. I definitely did not intend anybody to ever take these apart. Try to use a spudger, which is not sharp. Take less of a chance of slicing something that way. Okay. So really, we just have a printed carbon on the Mylar that's contacting something on a trace on the PCB. It's just a pretty standard setup, but with the Mylar glued down. Well, I'm going to have a look at this off camera up close just to see what we can see. Not only did I need to remove this top key pod, I needed to remove the one below it as well, and that got rid of the short. And the short was actually between the 1 and the Q keys, like they were both being held down. And I thought, well, maybe that was just a fault that developed in the membrane. You know, plastic tends to shrink over years and it could have caused a buckle or something. But then I noticed that both of these key areas had a little defect under it. And originally when I saw this one, I thought, well, maybe when I was trying to pry up the frame that I had hit that with the spudger. But it's like, well, what are the odds that I did the same thing here? And this is the second key in this case, not the first key. So, well, that would be a pretty slim chance I would happen to do the same on both keys that happen to have the problem. And then I got to wondering, well, if we've got this bad a spot here, what do those rubber pads on the key pods look like? And you can see there is something there. It's a little bit of schmaltz that's kind of dug into the rubber. So I wonder if some grit got under here over the years and, you know, repeated key pressings kind of dug into it, and it was enough of a mound to push the membrane down like the key was being pressed. Because the spacing between this black membrane and the PCB is, you know, only maybe 0.005 of an inch or something. There's another clear piece of plastic between them. So I don't know, maybe that was a defect from the factory that got worse over the years. It's kind of an odd thing. Unfortunately, I measure the short at the diodes and it's not there anymore. If I press both buttons at the same time with my fingers like this, it comes back. But I can't test it in this situation because some of the contacts in here, that when these key pods are on here and clamp down, they transfer some traces from this membrane to the PCB, which goes up here to the LCD connector. So we need to find a way to connect our key pods back to the PCB first. So if you're wondering why holding down the 1 and Q keys would cause a short between these two columns, let's just find our 1 key and our Q key. They're on the same row, and they're magically on the two columns we had the short in between. So you notice how all these keys here, these are keys you would normally hold down, you know, 2 at a time. They can't scan them like that. And all the modifier keys, you know, shift and control and whatever else are down here. So you can hold one of these and press one of the other keys up here and that'll work just fine. But, you know, pressing a couple of these at a time will cause weird things to happen, as we have seen. Here is our plan for modifying the key pods. You remember these have these little posts here, which went through holes on the circuit board. They were melted and pushed down, called heat staking, to hold it in place. So the idea is we trim these flush, put this in this fixture, which we line up with these pins through this aluminum plate, which gives us a drill guide. And then through all these small holes in this plate, we drill, which will drill through where these posts used to be, and it should give us a hole in order to put a number 0 screw. So I will try this off of camera first, and then I will bring you back to do the second one. Well, I got one of these done, so I will show you what I did on the second one. I took this sort of X-Acto blade and tried to whack off those posts like that. And after you do that, you kind of need to go at it from the other side. Make sure you get it flush. And if it caused any flashing to go in this corner, just scrape that out of there. And then just do that for all of those. I got all the posts trimmed off. And I am putting this on the little drilling fixture here with the alignment pins in place. And I'm going to take a little strip of Kapton tape here. I'm just reusing what I used on the first one, just to hold this plastic bit to the fixture. Okay, and we've got our fixture here. I'll pop that in. And there we go. Now we're ready for drilling. Well, the first time I used this carbide drill bit, which is 1 millimeter. I think that's like a number 60 in the wire gauge. But it's 40 thousandths, 1 millimeter. And I broke it on the last hole. Carbide drill bits are great, but they're very brittle. I checked through all my drill bit stash, and I happen to have one high-speed steel drill bit, which is actually better for this application, less likely to break it. So the trick here is you just go through the hole. You don't need to push down a lot. Just let the drill do the work. What would have been ideal is if I would have marked with some tape on this drill bit when I got far enough through. Didn't think of that though. There. That got a lot easier all of a sudden, so that's through. So now I've got 7 more of those to drill out like that, and then we'll move on to the next step. Now we've got all those holes drilled, so we kind of retrieve our little key pod from the fixture, like so. And you might just be able to see we have holes through the top. And yes, they do not align with those little dimples. That is how they are supposed to be. You can see they're right through the center of where the posts were. So I am also going to take one of the little itty bitty screws and just start it in each hole we just drilled out. So it'll be easier to install on the computer. Then after that, I'll clean up all these blue pads. This is the one that had the crud on it. It's fallen off. You can kind of see the scratches there, so we need to clean all that off there and make sure we don't have any shavings in this guy. Reassemble this, and then we'll try to connect them to the circuit board for the keyboard and see what happens. Okay, I've got one key pod reinstalled. What I did first was take a little very light sandpaper, like 400 or 600 grit, and sand down over where those bumps were on both. So hopefully that'll help it from wanting to try to keep the key pressed. And getting these guys put on there is a bit tricky. You've got to try to keep these rubber bits in the right place. Maybe we'll turn it this way. There. Sometimes when you try to push it up there, those pop out. But anyhow, keep these like that. And try to press it up there. And then get all your holes lined up. There, I think we're kind of lined up there. Grab a few screws. I wish I could have gotten slightly longer screws. These are number 0 and 1/8 of an inch long, which is 3.15 millimeter. I think 4 millimeter would have been ideal, but you got to go with what you can get. The next size was 3/16 of an inch long, which is 0.1875. So that's closer to 5 millimeters. I dropped. Where'd that one screw come from? Oh, that must have been on my screwdriver. Anyhow, I'm rambling. So, no. What's going on there? Oh, yeah, look. See how we got a rubber pad out of position. Okay. Anyhow, I'm going to have to do this off camera, but you get the idea. But you got to kind of hold your mouth just right and get everything aligned, hold it up against the board, get all the screws in there, and do not over tighten them. If this winds up working, I'll make sure they're all about the same torque, and we'll put a little paint on each one to keep it from backing out. I've been working on this HX-20 keyboard issue for 6 to 8 weeks now, and it's been more than a month since I've touched it. I just needed a break, and I was busy doing other things. Anyhow, you can see we've got, you can't quite see it with the glare, but I have it turned on, the keyboard hooked up. I found out I could pop loose the buttons and the spring underneath there when putting these on, which made this a lot easier. I've had these off a couple times, and I did wind up ordering the longer 3/16 inch long number 0 screws, which worked a lot better. Just the very tip, the pointy part of the screw sticks out, and that's not enough to hit the keycap, so it's fine. And now I can get them tight enough that it clamps down well. You can see I touched a key, so it's repeating. I'll restart this. So it's kind of in a state now. It's not working fine. I thought that these buttons over here weren't working where I had taken these key pods off, but I found out part of my notes here were wrong because some of the pin numbers giving on this schematic right here are wrong. So if we go into the monitor by pressing 1, it'll just repeat the last key press. There's still a problem with the keyboard, but this made a good keyboard tester, kind of ironically, so I was able to see what all worked and what didn't, and all of these keys that I had fixed over here. There we go. See, these all work. Just using this kind of rounded tip here to press that. Space doesn't work. There's a few others. I'm not sure again what to do, but mostly everything works. I made a list of What doesn't work, there's a few keys that tend to lock it up. Now, when I press it, some of these function keys up here, for instance, seem to lock it up. The insert delete kind of backs it up all the way, so it's like repeating itself. And it seems like the keys that have the biggest problem are in these two columns, which go through D9 and D10. So there might be some other issue here. There's some keys here which are not used, so if it thinks those are being pressed, this firmware might not know what to do. The way this particular computer works is there's actually two microprocessors. They're both derivatives of the Motorola 6800. It's the 6303, I think, is the part number. It's like a microcontroller version of the 6800. One is responsible for I/O, including scanning the keyboard, and when it has a key press to send to the other processor, which is running the programs, it says, hey, here's a key press, here's the key code. So I'm guessing what's happening is this is when it's scanning the keyboard, there's something it's not expecting, and that's causing it to think it needs to send a key code to the application processor, and the last thing in the key buffer is the last key pressed. That's my theory. And I was kind of off one number here. The pinouts they give in the manual for the cable coming from the keyboard is different than the pinout or the pin number on the main board, which was very confusing. And some of the numbers given here are also wrong. And I finally realized that when I was trying to test these keys, and I was one row off here. At any rate, I think what I'm going to do is pull a couple of these column diodes right here, D9 and D10. I'll do those one at a time. I think I can do that with the setting in this position, turn the power off, pull one, and see how it works. And hopefully that'll reveal where the problem is at on the keyboard so we can look at it more. That yielded results much faster than I thought it was. I first pulled up D9 because it was right on the end and easy to get to, and that made a difference. And then I pulled up D11, which is what kind of brings this extra graph key in here to that same column, just to eliminate that. That didn't really make any difference. That's this one right here. But with D9 pulled up, if we go into the monitor, you can see we no longer get our automatic repeating key press. I can type something and I just get that. If I hold this down, that diode D9, it starts repeating stuff again. And for some reason, the first time you touch it, it repeats Y. I don't know why. Anyhow, out of all of these keys in this column, the only one that doesn't really seem to do anything when I press it in this screen right here, in the monitor screen, is space. Space seems completely dead. The other keys, for instance, like num, it prints the wrong character, but it does something. Space does nothing. So I'm wondering if it thinks the space key is stuck down. So I think what I'll do is take all of this apart and we'll pull the space key, kind of like we did these two pods. It's in its own little single pod here. That shouldn't be too difficult. And we'll see what happens. If that takes care of the problem with that diode still connected, then we know that we've nailed it. And since this is right on the edge here, maybe we can fix it too. We'll see what happens. I removed that single key pod for the space key, and if we go into the monitor now, and I'm going to hold this diode down, that is for D9, which is right on the end. You can see it's not repeating. I can type in one key and I get one key. I haven't tried space yet. Yeah, space is giving us a Y for some reason. That's not right. There might still be another problem there. That is kind of weird. Why is the space giving us a Y? Maybe it's because I've got this other diode disconnected. Anyhow, it did seem like the space was stuck down. Yeah, the space is just giving us a Y. That's very strange. And the num is giving us a whack. I think I'm going to solder both these diodes back down and try this again. And then we can peel this membrane up and make sure there's no junk under there. The only other key that doesn't seem to work quite properly is the period. You have to press pretty hard on it. It seems to be getting better with time though. So I don't think I'm going to mess with that. I don't want to mess this whole membrane up now that it's 99% working. So we'll just play with that a lot and see if it gets better. And I'll solder these diodes back down and we'll see if that fixes the space key or if there is a further problem. Okay, we've got our space key pod modified and screwed back on there. And if I go into the monitor, you can see it's not repeating. I can type the key, space, and another key. That all works. Everything else seems to do what it's supposed to do. Yeah, I pressed the number key not here now, so it's switching these keys to a number pad. I still got to get all the springs and whatnot put back in these keys, which should be as simple as doing that. And, well, something like that. I'm going to have to squeeze these little tabs here to get it in, but anyhow, got to do all those and get it all back in the case and tested. Remember, we still have a wire soldered from the main board, the MOSU, to the keyboard to bypass high resistance trace in here. So when I went to put back the key stem and spring in here, it acted like the key was held down again. And I pulled the stem and spring back out and everything was fine. Set the spring in there with the slightest amount of pressure. Space was triggered, same thing for 1 and Q. These other keys, which were apart, weren't nearly as sensitive. So I don't know if that's from the membrane sagging with age. Maybe that rubber pad isn't as stiff, something. So I'll pop a picture up here on the screen. I cut a paper donut out of a sticker. It's about 4/1000 of an inch thick, 0.1 millimeters. Stuck it on the bottom of the blue pad. So the hole in that donut is about the size of the carbon pad that contacts in the middle of the membrane. So that worked fine. So I don't know if you'll be able to see the LCD really well, but if I type it in a space, these are about, all the keys are about the same sensitivity now. So that worked. Paper's not the ideal thing for that. It'll wear down relatively quickly. So I then try to think of how to do that with something else. A friend suggested Kapton tape. So I made some Kapton tape donuts using the drill press. Not drilling, but I put my hollow punches in the drill press and just used it as an arbor. That way it would keep the holes concentric. And then finished off the cutting through the holes with an X-Acto knife, and it worked out pretty well. I mean, it works. So I've got the space key fixed right now. And I decided, since I already had these pods all the way off, I would do every key on them. So I need 8 more, which means I need to cut 4 more than I have right now. And then I'll do the rest of these keys here. And this should be all fixed up. I was so proud of myself with those Kapton little donut ring things. It worked great for the space key. It made the one in the Q worse. So I wound up taking them out of there, and I come up with a different solution. I've since removed the ring from the space key here, and I'll show you how this alternative solution works. And you can do this without having to remove the key pods, so it may be a better solution in the long run. You can remove these stems by taking a little screwdriver, pressing in on the side right there, and just lifting up. So you're pushing in that catch and kind of lifting up slightly at the same time. This reveals the spring. Here I have a 3 millimeter long piece of ink pen spring. Just out of a pin like this. I took it out of that pin, as a matter of fact. I cut it off about 4 millimeters long and then bent the top down to try to make a flat top, so it's about a 3 millimeter length. And we're just going to place that over this spring, if we can get it to go down there, and see it stops on this little post right here that this long spring goes through. And we'll put the stem back on, and the short spring is going to press up against this white part and the black part to keep the key up. And then when you press it down, it'll put enough pressure on the small spring, which presses on the pad. Now, hopefully that'll also work for this space key. I don't know, I haven't tried it yet. If not, I'll have to put the little donut back in there for this one. I don't know what the difference is, if the layout on the membrane is a little different on the space key versus the other keys. So we'll give it a try and see what happens. But I wanted to show you how you could do that for at least most of the keys without having to disassemble everything and go crazy like I did. Okay, moment of truth. We'll turn it on. Go into monitor. Nope. We're going to have to put the donut back in the space key. That's interesting that this is required two different. Yeah, see if I lift that up, it stops repeating. I don't know if you can see the LCD really well. Okay, so on the space key we need the donut. On the one in Q, the little pin spring did the trick. So I'll put the donut back in and get the keyboard assembled back in the case and try everything again. So I've added some paint lock to the screws that we added to the keyboard pods, and some tape to hold our jumper wire here all the way along. Keep it in place, and we're ready to close this thing up again and test it for a few days. Well, this certainly has been an interesting repair. It all came down to 3 of the keys on the keyboard acting like they were stuck down, and the symptom with that was different than any other computer that I know of. Most vintage computers, if you have one key held down while it's in and it repeats and you press another key, then you'll get one instance of that first letter on the display, and that's it. On some of them, if you continue to hold down the second key, it'll start auto-repeating, but the first key won't. This is the only one I know of that gives you this, the last key pressed auto-repeats forever. That's rather interesting. And it kind of threw me off there for a while. We did get there eventually. We found a way of taking the key pods off of this keyboard, which was non-repairable, and actually repairing it. We had to use a variety of methods there. A couple different MacGyver techniques with the Kapton donut, as well as some pieces of pin spring to get everything working again. I do think this means that if somebody were to create a new membrane for this, it would be possible to install it by taking off all the key pods. That would be a lot of work, but it would probably turn out okay if you had the patience. If you have any questions or comments, well, just let me know in that comment section down there below. I certainly would love to hear from you. And thanks to everyone who helps support the Hey Birt channel through Patreon and other means. I really appreciate it, and you keep this channel going. Well, until next time, bye.